Hello friends, so in this video we will learn how we can design a smart irrigation system project by using Arduino and by using different sensor. So you can see on the screen we have the rain sensor, then we have the DST11 sensor, then we have the moisture sensor, also we have the mini water pump motor which pump the water from this tank and upload some water into this tank, and then we have the LCD to monitor the status of this sensor. So before start the project I would like to tell you what is the flow of this complete project. We have the DST11 sensor which is used to sense the humidity and the temperature value of the atmosphere, and that humidity and temperature value continuously printing on the LCD screen. Um, you can see on the screen like here humidity is 73%, temperature is 26%. So that is the use of this humidity and temperature value. Next we have the moisture sensor. You can see I have connected this moisture sensor. So you can see I have this moisture sensor, and this moisture sensor I have dropped here. So basically use of that moisture sensor, it is used to detect the level of this water. Maybe you can put this moisture sensor into another tank which detect the level of this water, or maybe you can put this moisture sensor into the plant so that it can detect the level of the water. So this is basically use of the moisture sensor to detect the level of water. Next we have the relay module which is used to turn on and turn off the water pump, and after that we have the rain sensor which used to detect the rain. So flow of this project is like that: whenever this moisture sensor detect the low level of water, then automatically this relay will turn on and that water pump start pumping the motor into this tank. So this is one operation. Now in the second case, if the level of water is increases, then automatically this motor will turn off by using this relay. So once this relay will turn off, this motor also turn off, and this happen when the water level increases above a threshold limit. Now let's say there is another condition: if the water level is below and this motor start pumping the water, but in that case if the rain come, then automatically that motor should be stopped because rain is detected. So to detect the rain we have the rain sensor. So this is the complete idea behind this code. I hope you understand the idea behind this project. Now we will see the practical demonstration of this project. So I will reset the board. So once I reset the board, you can see on the LCD there is a project name display, and then after that sensor value. So I will reset the board. So you can smart irrigation system, then moisture level, then temperature, and then the moisture level value. So currently moisture level value is 549. So once I remove the moisture sensor from this tank, then moisture level value is decreases, and sensor gives the opposite value to Arduino, like the sensor value is increased. So once the moisture level value above 700, then this motor will start. So I will remove the this moisture level from the tank. So wait for some second. Now you can see motor start pumping the water, and that water gets filled into this another tank. Now I will put the moisture sensor again this tank so that water is detected and moisture value also water level also detected. Now you can see once I place the moisture sensor into this water tank, then water level detected by moisture sensor which is increases which is lower than the threshold, so automatically motor will stop. So this is the one flow of this project. Now will I again reset the project. Now we will see the second condition. If I remove the moisture sensor from this water, then what happen if the rain is detected? So in that case, if the rain is detected, that motor should be stop working. So I will remove the moisture sensor from this water. So you can see motor start working. Now I will put some water on the rain sensor so that it will detect the rain. So I will putting the some water droplet on this sensor. So you can see once I put some droplet on this sensor, then motor stop working, that means rain is detected. So this is the complete flow about this project. So I hope you understand the practical demonstration of this project. Now we will see the how to connect the each and every hardware with the Arduino, and then we will see the programming part. So this video may be 30 minutes or 40 minutes, but with this video you can able to complete this project by yourself. I request you please subscribe my channel. Currently you can see I have uploaded more video on the many video on Raspberry Pi, Arduino, then Python program, then some webinar, so that it can grow your career. So if you want to learn something from me, it is free, and you have to just click on this subscribe button, and all the video, it is very unique, and you will learn definitely many things from me. I uploaded mostly video on Raspberry Pi, mostly video on IoT, then Arduino. There are different types of project I have explained, and each project having the programming part. So please subscribe my channel, please support me, and please enhance your knowledge by watching my video. So now I am going to tell you how I created this circuit, 0 PC circuit, by my own. So first of all, whenever you buy the LCD on the Amazon, you will get only this green LCD. You have to create this circuit by your own on 0 PCB or on breadboard. So you can see the similar connection is here. So this is my main LCD. You can see 16/2. So there are 16 pins on this LCD. You can see 1 to 16. So first pin should be connected to ground directly, ground, and this is nothing but the 10K potentiometer. So you have to purchase 10K potentiometer. You can see this is the potentiometer you have to purchase. This potentiometer or any type of potentiometer which having the 10K value. You can also purchase this one also, or this one also, any potentiometer, this one also. Basically each potentiometer having the 3 pins. You can see these 3 pins, these 3 pins. So first pin should be connected to the VCC of this potentiometer. Second pin is nothing but the middle one pin. You can see this one is middle one pin of potentiometer. So you can consider this one, this middle one pin of potentiometer, or this middle one pin of this potentiometer. So connect the middle one pin to the VEA pin, and the third pin of this potentiometer should be connected to ground. That's why VCC also connected to ground. Then VSS is nothing but the ground pin of LCD, that is the first pin. You can see this is the ground pin of LCD, this is my VCC pin of LCD, common ground and common VCC. And then you can see till this part all the pins are same. So and this part is nothing but the controller pins. You can replace any controller at this point. So if you want to connect D4 pin, D5 pin, you can take it from this one, this one, this one, this one, and this is nothing but these 3 pins. So and this resistor is nothing but this one resistor, 560 ohm resistor, and this pin is LED negative pin, that is 60 number, is connected to ground directly. So connected to ground here directly. So this is connection I made by using this circuit. So I hope you understand how I created this circuit. So once you can design this circuit till this point, you can see till this one and till this point. So you can directly connect any number of LCD pin, any LCD pin to any controller, and this represent the controller pin basically. So you can replace any controller at this point. Whenever you require Raspberry Pi also, you can require Arduino also, you can just do the plug and play. You can just do the plug and play with this circuit with this point. So this is common VCC point, this is common ground point, and this one is your input point which reflect this this pin basically. Okay, once you create this circuit on this 0 PCB or on breadboard, now we will connect one by one pin to the Arduino. So first pin we have to connect is RS pin of LCD. So this one, first one pin is RS pin of LCD, and this should be connected to 2 number pin of Arduino. So you can see on Arduino, there is a pin number, so we can easily connect that pin number as per the program. So program explanation we will see later, but first connect RS pin of LCD to 2 number pin of Arduino. So 0, 1 and 2. Now second pin is enable pin of LCD, that is this one pin, and this should be connected to 3 number pin of Arduino. So enable pin should be connected to 3 number pin of Arduino. Now the next part is D4 pin of LCD should be connected to 4 number pin of Arduino. So this is a D4 pin, and this should be connected to 4 number pin of Arduino. Then D5 pin should be connected to 5th number pin of Arduino. Then D6 should be connected to 6 number pin of Arduino. So D6 pin of Arduino, and this should be connected to 6 number pin of Arduino. Then D7 pin of Arduino should be connected to 7 number pin of Arduino. So D7 pin of LCD should be connected to 7 number pin of Arduino. So we have connected one by one pin to the Arduino. So I will again repeat, RS pin should be connected to 2 number pin of Arduino. Enable pin of LCD should be connected to 3 number pin of Arduino. Then D4 pin should be connected to 4 number pin of Arduino. Then D5 pin should be connected to 5th number pin of Arduino. Then D6 pin should be connected to 6 number pin of Arduino, and D7 pin should be connected to 7 number pin of Arduino. So this is the common this is the connection of LCD. Now the next part is you have to again create this common VCC and common ground circuit. So you can see this is my common VCC and common ground circuit. So whatever the VCC pin of Arduino I will take here, and whatever the ground pin from Arduino I will take here, and this will be act as a common VCC and common ground. So you can see thus I have solder on one side is solder and second side is solder. So this side work as a common VCC and this side work as a common ground. So why this is basically used? Because our Arduino having only 5 voltage, 2 pins and the 2 ground pin, but in our project we have the many sensor. So to connect many sensor to common VCC and common ground, we have connected this one. So you can also build this circuit on the breadboard also, there is no issue. So first we take the common ground pin from the Arduino. So this is the ground pin from Arduino, I will take the common ground pin, and second is common VCC pin from the Arduino, I will take here common VCC pin. Okay, now the remaining part is LCD VCC pin. So you can see this one is my LCD VCC pin. So I will connect this LCD VCC pin to common VCC point. So this LCD VCC pin I should connect it to common VCC point. Now LCD ground pin again connected to common ground pin. So this is the LCD ground pin, this one is LCD ground pin. So I will take this ground pin and this should be connected to common ground again. Okay, so in this way we have completed the circuit connection of Arduino with LCD. Now we will see how to connect the DST11 sensor with Arduino. So you can see we have this DST11 sensor. You can order this DST11 sensor from the Amazon or from the Flipkart. So each DST11 sensor having 3 pin, VCC, data and ground. So first what we have to connect, VCC to common VCC, ground to common ground, and data should be connected to 9 number pin of Arduino. So connect that as per this one. So this is DST11. So first pin is VCC pin. So this is the VCC pin that should be connected to common VCC point. Then this pin is ground pin, and the ground pin should be connected to common ground pin of our point. Okay, and the last one is this one, data pin, and this should be connected to 9 number pin of Arduino. Okay, so in this way we have completed the DST11 circuit with the Arduino. Now we will connect the range sensor circuit with the Arduino. So you can see whenever you buy the range sensor, you will get this type of range sensor, and again each range sensor having the 4 pin. You can see at this point. So you can see each range sensor having the 4 pin. This one. So these 4 pins are first VCC, then ground, then D out and analog out. So we will first connect the VCC pin to common VCC again, ground pin to common ground pin again, and we will use the analog pin from this range sensor, and this analog pin from this range sensor should be connected to A1 number pin of Arduino. So first I put the range sensor here so that we can connect easily. So I will put here. Okay, now first part is VCC pin. So take take VCC pin from this range sensor. This is the VCC pin, and that should be connected to common VCC point again. Okay, next pin is ground pin, and that should be connected to common ground pin again. Okay, and the last pin is analog out, and analog out should be connected to A1 number pin of Arduino. So A0 and A1. Okay, so in this way we have completed the range sensor circuit with the Arduino. Now the next we will see how to connect the moisture sensor with the Arduino. So again same, whenever you buy the moisture sensor from the market, then you can see this moisture sensor you will get, and this one may be the separate. Then you can connect this moisture sensor to any pin. There is no polarity for this, so you can connect any one pin to any one this at this number. So again you can see here, here again the 4 pin you can observe. So again the same VCC, ground, analog out and digital out. So first connect the VCC to common VCC, ground to ground, and analog pin to A0 pin of Arduino. So I will put my moisture sensor here. Okay, so first we will connect the VCC pin from this moisture sensor to common VCC point. Okay, now the next is ground pin from this moisture sensor should be connected to common ground. So ground pin from the moisture sensor to ground pin of Arduino. Okay, now the next part is analog output pin A0 pin of moisture sensor should be connected to analog pin of moisture sensor should be connected to A0 pin of Arduino. Okay, so in this way we have completed the moisture sensor part with the Arduino. Up till now we have completed the LCD module, rain sensor module, DST11 with Arduino, and then the moisture sensor with the Arduino. Now next part is we will connect the relay board with the Arduino. So you can see whenever you have the relay board again having the 3 pin VCC, ground and input. So VCC should be connected to common VCC, ground should be connected to ground, and input of this relay board should be connected to 8 number pin of our Arduino. So connect the same connection again, VCC pin to common VCC, okay, then ground pin from this Arduino should be connected to common ground. Okay, now the next part is input pin of this relay module. This is the input pin and that should be connected to 8 number pin of Arduino. Okay, so in this way we have connected the relay module with the Arduino. Now only the last part is remaining, this water pump, mini water pump. Whenever you buy this water pump, mini water pump from the Amazon or from the Flipkart, this water pump having the 2 pin. So one pin is red and the second pin is ground. So one red pin is working as a positive voltage that requires the 5 volt, and a black pin work as a ground. So first connect red pin to the common VCC. So red pin should be connected to common VCC. Okay, now what you have to do for the ground pin of this motor. So ground pin should be connected to middle one pin of Arduino. So you can see on the middle one pin of relay. So you can see relay having the 3 pins, this one and this one. So middle one is common pin, this one is open collector, and this one is closed collector. So middle one pin of this relay should be connected to negative pin of your motor. So this is my negative pin of motor. You can see this is the motor, and motor having the negative pin, and that negative pin should be connected to relay middle one pin. So I have connected this pin to middle one, and this pin I have connected to motor. Okay, so this is the one part. Now the next part is second one. This one pin, open collector pin of this relay board, should be connected to ground pin of our circuit. So common ground, we have common ground, so connect this to the common ground. So in this way we have completed the circuit connection of the project. I hope you understand the relay circuit connection. It is very important to understand, and if you don't understand, please watch this video again. You will definitely understand each and every connection of this project. Okay, now we will see the programming explanation of this project. So before start the programming explanation, you need to install the Arduino software in your laptop. If you haven't installed the Arduino software in your laptop, please watch my this video, protest simulation accident and alcohol detection video. There is one chapter how to install the Arduino in your laptop. Follow that chapter and you can easily able to download this software into your laptop. Okay, after you download the Arduino Uno software in your laptop, next point is you have to download Smart Irrigation System code from my Google Drive link, the Google Drive link given in the description. So once you download this code, double click on this code. So once you double click on this code, this code will be open. The another option to open the code, open this Arduino software. Then go to the file, then go to the open and click on the downloaded folder. So this one is my code, so click on, go to that code and click on open. So in this way also you can open the folder. Now next point is we have to install the DST11 library in your laptop. So how to install this DST11 library in your laptop, we can see, go to the tools, then after that go to the sketch, then after that include library and go to the manage library. So once you click on the manage library, you can see, first check internet is connected or not to your laptop. Then after that search here. So wait for some second, this will upload completely. Okay, once it upload completely, just go to here and search DHT11. So once you type DHT11 and click search, once you click on this enter button, then DHT11 library will pop up here. So we have to search the DHT11 library. So you can see this is library, you have to install DST sensor library, and here you can see this install button, like here you also see the install button. So whatever the DST library, click on this install button and that DST library get installed in your laptop. So in this way you can install the DST11 library. Okay, now you have downloaded the DST11 library, you have downloaded the Arduino code. Now next part is we can see importance of each and every line from the code. So first line is hash include liquid crystal.h. So basically whenever you want to use the LCD in your project, then you require this library. DST library is basically whenever you want to use the DST11 sensor in your project, then you can use this library. Next part is we have defined RS, enable D4, D5, D6 and D7 pin number here. So RS pin we have connected in hardware like 2 number, then enable pin we have connected to 3 number, then D4 pin is connected to 4 number, then D5 is 5 number, then D6 is 6 number and D7 to 7 number in the hardware. So whatever the hardware pin we use, that pin we have defined here. Then after that relay pin we have connected to 8 number, then DST11 pin number we have connected to 9 number to the Arduino, moisture sensor we have connected to A0 and rain sensor we have connected to A1. So whatever the hardware connection for the circuit we define here. Now the next part is we define one variable for DST11 sensor. Then after that there is some global variable which can store the value of moisture sensor and the rain sensor. Then after that we store the value of humidity and we store the value of temperature value. Now next part is we have to define the sensor type for moisture sensor. So sensor type is DST11, so that we have defined that sensor type here. So in this case if you use DST22 sensor, then you can use DST22. So whatever the DST sensor you use, that we have to define here. So you can see we have defined DST11 sensor here. So that is important of this line. Now the next line is void setup. So basically the setup functionality of the project, like defining the input output pin, defining the baud rate, that all comes in this setup function. So first line is serial beginning 9600. So we are using the baud rate 9600, so that we have defined the baud rate here. After that we have connected the relay pin as output pin, because Arduino send the signal on the relay pin. So to define any pin as output or input, we use this functionality pin mode, then pin number, then output or input. So pin number we have defined relay pin as a 8 number already here, so that variable we use here, and we define that pin as output by using pin mode functionality. Then after that we define LCD beginning 16/2, because we are using LCD 16/2, so that we define the configuration of LCD here. Now next part is we are printing smart irrigation system on the LCD, so that these 4 lines, basically these 3 lines are used. So first line will be print smart irrigation on the first row of LCD, then on the second row cursor will move, then on the second row system will be print. Then after that we have to turn off the relay at the starting. So to turn off any digital output pin, we use this logic digital write, then pin number, then send the low signal. So to turn off the relay, we send low signal, and to turn on the relay, we will send high signal here. Then DST beginning, basically this start the DST sensor, and there are some delay. Then after that void main loops will start. So whatever the code inside that void main loop, it will execute for infinite number of times. So first function is read DST sensor. So pointer will jump to this function, and then first point is humidity value. So dst.read humidity, this functionality will read the humidity value, and that functionality store that humidity value into this humidity variable. Then after that same dst11 read temperature. So this function will read the temperature, and that temperature will store into this temperature variable. Then here we are checking if the temperature value is not none or humidity value is not none. If the both value is none, that means humidity temperature sensor is not properly connected with your Arduino. So then it will give the message fail to read the temperature sensor. So I request please properly connect your DST11 sensor so that you will not get this message. Okay, then after that we are printing this humidity value on the serial monitor, also humidity value on the LCD. So to print the value on the serial monitor, there is a function serial.print, then humidity it will print, then serial.print humidity value. So it will print humidity and then value, then percentage, then LCD clear. Then we have to print the humidity on the LCD. So how to print the humidity on the LCD? On the first row we will print lcd.print humidity. So this name will become, on the second row actual value will become by using this function lcd.print humidity value. So basically humidity value we are stored in this variable so that we print same variable on the LCD. Then /n, then after that there is some delay. Then same temperature value we have to print on the serial terminal. Also we have to print the temperature value on the LCD. So how to print the temperature value on the LCD? LCD print, then temperature degree Celsius. Then it will print on the first line, first row of the LCD. Then array move to the second row of LCD, and the second row of LCD we will print temperature value. So whatever the actual value that store into variable, that will directly print on the LCD. So in this way humidity and temperature value print on the LCD. Then moisture level detector function gets called. Then cursor move to this moisture level detector detector function. Then after that analog value. So whatever the analog input on A0 pin given by the moisture sensor, that will be read by this functionality analog read function. Then after that whatever the value coming from this sensor, that will be stored into this moisture sensor value. Then after that serial.println moisture level. So on the serial terminal we are printing the moisture level. Also we have to print the moisture level on the LCD. So how to print moisture level on the LCD? LCD print moisture level, it is on first row. We have to jump to the second row for actual value, then moisture value. So this is the value. So that value will be printed on the LCD by using this line LCD print. Then there is some delay. Then after that third function will be execute water motor start. So inside this water motor start you can see first we will check the rain input. So analog read rain sensor. So rain sensor again having the analog sensor. So this will give the analog value to the Arduino, and that value will be stored into rain sensor value, and that value read by using this analog read functionality. So we are printing that value on the serial terminal, and if the rain sensor value is greater than 700, that means rain is not detected. So if the rain is not detected, then check the moisture level value. If the moisture level value is greater than 700, that means moisture is little bit low, so that turn on the relay. So to turn on the relay, again the digital write, then relay pin to the high. Let's say if the moisture level is below 700, that means water level is there, water is present. So to turn off the relay, so else part will be executed, and we have to turn off the relay by using digital write relay pin low. So in the second case, if the moisture level is greater than 700, in this case relay will turn on, and the next part it will check the rain sensor, and if the water detected by the rain sensor, then else part will be executed, and in the else part relay will turn off. So this is the complete idea behind this code. I hope you understand the code. If you don't understand, please watch the video again. You will definitely understand the code. Now we will see how to upload the code into the Arduino. So first you have to connect your Arduino with your laptop. So I have connected Arduino now. Then after that go to the tools, and then go to the board, and here you have to search Arduino Uno inside Arduino AVR board. So select this Arduino Uno, then after that again go to the tools and search this port COM port. So in my case COM port is 5 for Arduino Uno. In your case COM port may be different, so select that COM port. Then after that upload, click on this upload button. So once you download my code, and once you follow all the procedure, then code start uploading on the Arduino without any error. So you can see here done uploading, that means code is uploaded in the Arduino. So in this way you can upload the code and start working on this project. Thanks for watching video. If you like the content, please click on the subscribe button and click on the like button.